11.1 is on the distance formula and circles. The distance formula can be derived using the Pythagorean theorem as shown on the right here. You basically have your 2 points, x1, y1. The subscript of 1 is just indicating it's the first point. x2, comma y2, again the subscript indicating second point. It doesn't matter which point you call 1 and which point you call 2. You just have to stick with what you consider point 1 and point 2. So either this has to be 2 and 2 and 1 and 1, or these 1s and these 2s. So the distance formula then is, if you're deriving it from Pythagorean theorem, is a squared plus b squared equals c squared, where the c has to be the hypotenuse and the a and the b the legs of a right triangle. And by dropping down your vertical and a horizontal line here, you create a perpendicular situation, therefore a right triangle is formed, and so you can find the distance between the 2 points using Pythagorean theorem because you have a right triangle. The hypotenuse would be the distance between the 2 points, and the legs would be basically the rise and the run. So instead of doing like rise or run for slope, you have your rise squared plus your run squared, or run squared plus rise squared. It doesn't matter which order you put this in. I normally do x's first, then y's, but that's just me. Would equal the hypotenuse, which we'll call d, the distance, squared. But we're not looking for the distance squared, so we can take the square root of both sides, leaving you with the distance being the square root of x2 minus x1 squared plus y2 minus y1 squared. So I have an example worked out here. Just a reminder, like when you were doing slope, when you have a subtraction as part of the equation, if you have a negative, you end up having a double negative, and therefore instead of subtracting a negative, you can say you're adding. Following order of operations, we'll do what's in the parentheses first, and then we'll do our exponents, and then our addition. So the distance is the square root of 61. However, we rarely say, oh, go a distance of the square root of 61 meters away. And so it's often helpful to recognize what the approximation is. It's also helpful if you are going to be trying to sketch a related situation or plot a related situation. So taking your calculator, you can take the square root of 61 and round to, tenths or hundredths, depending on how much accuracy you want. Typically, tenths is good enough for graphing purposes. In any case, there's the exact answer. Square root of 61 does not simplify as an exact. However, if you work this problem out, you'll see that it actually can simplify for this problem. So you can also use the distance formula where you can't use Pythagorean theorem for a problem like this. You can't use Pythagorean theorem because you can't plot and use the lengths of the 2 legs and do a squared plus b squared equals c squared because you have a variable here, x. However, you can make use of the relationship between the distance and the points using the distance formula. So there's the distance formula just to reference it. And x2 minus x1 squared plus y2 minus y1 squared. Again, you can simplify what's in the parentheses, well, not that one, but this one, and your distance is a square root of 13. And so once I've simplified what I can, I want to solve for x, and so I need to isolate it. So I am going to have to undo the square root. I'm going to have to get rid of it. So I'm going to square both sides. That will also get rid of the square root of 13. So 13 will equal x minus 1 squared plus 9. Again, to get x by itself, we need to undo this addition here. And then we'll need to undo the square by taking the square root of both sides. And then when you take the square root, don't forget you have plus or minus 2 And then when we add 1, we either have 3 or -1. And both of those are legitimate answers. There's no extraneous solution on this one. And I sketched it over here just to kind of illustrate that it can be 3, 2 as your coordinate, or -1, 2. So there's the original root 13, and root 13 could be lying on a circle where the height is 2. We just want to know these x's, so we found them, -1 and 3. The next part of this lesson is on circles. So circles, there are different formats to write a circle in. The one that's the easiest to graph from is this version, which kind of reminds me of like that vertex formula for a parabola. We also saw this HK business for rationals. And we'll see it later for ellipses and hyperbolas as well. So for circles, here is the standard form. There's also a general form. I'm going to come down here just to show you. So circles can be written in this form. It's called the general form. And this is a general form for any conic. So if you have both x being squared and y being squared, you're going to either have a circle or an ellipse if they're positive. If there's a negative involved, a hyperbola. And if it was only one variable squared, like x squared or y squared, then you'd have a parabola. If the x is squared and the y is not, then it's the regular parabola, opens up or down. And you'll learn in the next lesson, if you have your y being squared and just an x, no x squared, it'll be a parabola opening up to the right or to the left, a sideways parabola. Essentially, you could solve it, and you'd have the positive square root, and you'd have the negative square root, and so you have a sideways parabola. So in any case, the standard form is here. I'm going to zoom back up here. Okay, so x minus h squared plus y minus k squared equals r squared, where the center is hk. So just like before with parabolas, what's in the parentheses you take the opposite of. If it wasn't in parentheses, you keep it as it is. But both of these are in parentheses, so it's opposite and opposite of what's showing. So it's hk for your center, and your radius would be r. The radius can go, in any direction from the center to the circumference of the circle, the perimeter of the circle. So if you're given an equation for a circle and you want to know what the radius is, you're going to have to take the square root. If you are told the center and radius, you will again do opposite, opposite, and you will square that radius value. So we're going to practice going both directions in the following problems. So here we have a center, hk, and a radius r given to us. So we're going to plug it into the formula. X minus the h, so x minus 3, again, it looks like the opposite, squared, plus y minus a -2. Minus a negative, same as plus. So again, it ends up looking like the opposite, equals your radius squared. 7 squared is 49. So this would be the simplified version. Part B, same thing. X minus the h, the x coordinate of your center, squared, plus y minus your k, which is the y coordinate of your center, squared, equals the radius, which is square root of 15 squared. When you simplify this, that's just x squared, y minus 4 squared, and you're keeping it in the format that's easy to graph. You're not like going to distribute this and get it into the general form. You'll keep the standard form here. And then the square root and the square will cancel to give you 15. So when you go to graph these, you go to your center, 3, -2, and you go out in every direction that you can count 7 units. So if we go straight along our grids, we can count 7 units. So we can go right and left and up and down, and those 4 points will allow us to will guide us to making our circle. For part B, again, you plot your center 0, 4, and this time the radius is square root of 15, so that's not an exact value that I can plot, so I'm just going to have to do my best to approximate where it would be, what the circle would look like. So root 15 is approximately 3.9, so I went 1, 2, 3.9, almost 4 units away, again, both to the right, left, up, and down to make some guiding points to make my circle. So let's go the other way now. Let's go from having a equation to writing down what the center and radius is, therefore being able to graph it. So it's the opposite and the opposite of what's showing. And then this is r squared, right? So if this is r squared, we would take the square root and r would be 3. So you might recognize that without having to write the equation, but sometimes it's just good to remember that this is r squared. I have students that just want to consider that there are. So then they say, oh, well, r squared would be 81. But again, we're trying to figure out r, and in the equation, it's r squared. Technically, when you take the square root of something, you know, it could be, when you're solving an equation, it could be positive or negative 3, but really it's just the principal square root you're doing, just the positive square root, and that makes sense because you couldn't have a radius that's negative anyways. So part B, nothing else is here, so it's kind of like, you know, 0. It's x plus 0 or minus 0 squared, so 0, and then the opposite would be, that's showing, would be 3. So y minus k, the k has to be 3. And then again, this is your radius squared. So your radius would be the square root of that, which is 5. Plotting it like we've done before. Part C, this one is going to be negative 5, 0, and the radius is going to be the square root of 12, which we can simplify as 2 root 3. When we go to graph it, we'll think of that as about 3.5, the approximation of root 12, or the approximation of 2 root 3, since these are equivalent. So this next equation is giving you some information about the circle. So it's not directly giving you the center and radius. It gives you the center, 2, 1, and a y-intercept. So a point that would be on the circle happens to be on a y-intercept. And then we would need to find the distance in order to know what the radius is. We have the center, we have that part, but we need the radius to get radius squared. So the radius is the distance between the center and a point along the circumference. So we can find the radius's value by finding the distance between these 2 points. So we use the distance formula between the 2 points. 0 minus 2 squared plus 3 minus 1 squared. And then we take the square root. And following order of operations, we end up getting the distance as the square root of 8, or 2 root 2. And as an approximation, about 2.8. And we can kind of check that if we go 1, 2, that is about 0.8 if I made my circle. With that, it would all line up very nicely. So when I did my radius here, just as far as the sketch is concerned, I plotted the 2 points, but I wanted some more guiding points. So I just went that same distance. So it's 1 root 2, another root 2, yeah, 2 root 2s. But in any case, it's 2 diagonals here. So we just keep going in the other direction, and then as a perpendicular, because, well, here we have a perpendicular situation for our guiding points. So we do x minus the center x coordinate, so minus 2, and then square that, plus y minus the y coordinate of your center, so minus 1, square that, equals the radius squared. And when you square the square root of 8, you'll just get 8, as you can see right here. Radius was root 8. When I square that, I square root 8, The square root and the square cancel, leaving me with 8. Similarly, we have a problem where it didn't give you a y-intercept, it just gave you another point. So again, you find the distance, and this time we'll have a slope here of rise 1, 1, 3, rise 1, 1, 3, so we can get that guiding point, that guiding point, and that guiding point. And once you find that the distance is root 10 or about 3.2, you can go 1, 2, 3.2 and get some more points, or just, you know, to confirm that it works. But you really shouldn't be going, oh, it's 1, 2, 3 and something, because that's not very accurate. That's why we use the distance formula. So the equation is based off of the center and that radius, which is the distance between the 2 points that we found here. So it's x minus 2 squared plus y minus 5 squared equals square root of 10 squared. So again, square root of 10 squared would be just 10. Use the exact, don't use your approximation when you go to write the equation with the radius squared, because this is an approximation. You'll have a rounding error and it won't mark it correct. I'm going to skip down to this bottom one for a moment and then we'll go back up. Similar situation here where they give you some information about points on the circle. It gives you that the center is somewhere on this x-axis and that the circle has x-intercepts at -2, 0, and 8, 0. And since the center is on the x-axis, it's going to be right in the middle. And so right in the middle on the x-axis would be right here at 3, 0. And you can just count because you're, it's not at an angle, you literally are 5 units away, so your radius is 5. So you have x minus the 3 squared plus y minus 0, so squared, which is y squared, equals your radius 5 being squared, so 25. So there's, sometimes you're given a conic, which is a cone and a cross section of a cone. And when you take a cone and you do a cross section where you're parallel through it, it will create a circle. And so we can rewrite this into this format. So this is our goal, is to have a perfect square plus another perfect square on the left side and then equals something else. And so we can take our general form where it's all multiplied out and use completing the square to take our x terms and complete the square, take our y terms and complete the square. And that constant will go over and we'll complete the square. So here it is. So I put my x terms together and my y terms together. They're already done like that. They aren't always, as you can see here. Often they put it in standard form where it's highest exponent. Then it goes down from there. So this one's already one step into the process. X's are together, y's are together. We're going to get the constant over on the right-hand side, which is very typical for completing the square method, as you've seen in prior lessons. So completing the square, we take half and square it. B over 2 squared is the formula. So take half and square it, you get 16. What you do to one side of the equation, you do to the other. Half of 10 is -5. Square that, you get positive 25. What you do to one side, you must do to the other. And then I can rewrite this as a perfect square. So again, meeting up with this goal in mind. So it's x plus 4 squared, again, half of it, or you can just think about what multiplies to 16 and adds to 8? Well, 4 and 4. So that's why it's x plus 4 and another x plus 4. So an x plus 4 squared. Again, the a is 1. Again, a is 1. And that's important. When a is not 1, you get other shapes, which you'll learn about in future lessons and future classes. So this one would be x minus 5, and x minus 5 would make this trinomial. So y minus 5 squared. And then adding these constants up, you get 49. So that makes an equation in standard form. It is a circle. If we were to go further in conics, you'd also know it's a circle by, if you tried to divide by 49, you would have the same x distance and y distance. So if you go the same in the x and the y, it creates a circle. Versus if they were different, if you had a coefficient, then you'd go a different distance in the x and in the y, creating an ellipse. And then if you have a negative in front, you end up with a hyperbola. Okay, so here's another example. The x squared, there is no other x, so it's already a perfect square. We'll complete the square for the y terms, and we'll get the constant over on the right-hand side. So half squared means you'll add 9 to both sides. That's a perfect square. This is y minus 3 squared. That's 20. So the center would be 0, opposite, so 3, so 0, 3. Your radius would be the square root of 20, because this is radius squared, and the square root of 20 is 2 root 5, or approximately 4.5. So I hope that gives you a good start on how to do circles. I'm going to bring up the homework and show you a few of those, and then we'll be done. Let's see. Okay, so the first couple just ask you to find the distance between some points. This would ask you to find an x. We had an example like that. Here it gives you a center and radius and asks you to write the equation. When you do that, just be careful that you are taking the opposite for both the x-coordinate and the y, that you're squaring both, and that you have a plus in between. Y would be plus 6 squared equals, and then you're going to square the 6 because it's radius squared in the equation. Make sure that it matches up and the syntax is okay, and you'll be good to go. Again, when you square the square root here, it'll end up equaling 3 for your equation of a circle. For graphing, it's 0 and 0. So this one's centered at the origin. You're going to use the circle tool. You're going to go to the origin, as this shows, origin and some point on the circle. So I'm going to go to the origin. And then since the 16 is your radius squared, your radius is 4. So I'm just going to go out to the 4, click down, and there's my circle. And then they ask you for the center and radius. So 0, 0, and the 4 that you use to graph. So here you go to 1, 1, and you go to the square root of 18. And so you just, oops, you needed the circle. So you go out and you can see that it's letting you pick what it is. Square root of 18, it's square root of 16 would be 4. So it's a little bit more than 4. 1, 2, 3, 4, and a little bit more. And you'd actually want to try to do it as accurately as possible. It is a little bit forgiving. I mean, you can see that they kind of have some control over where it is. But as I said, a little bit more than 4. Okay. And then here you need to complete the square in order to then find the center and radius and then graph. The 2 is already there, so you just get the x's together, the y's together, complete both squares. Get x's together, get y's together. This is going to end up being a fraction. You'll add it with that fraction, and just make sure you have common denominators to add your fractions. Then this one is asking you to write the equation. It says it passes through the origin. So when you're counting, you don't want to go 1, 2, 3, and half, because we're not sure it's exactly 3 1/2. But we know it's through the origin, so you'd want to use the distance formula to find the distance between these 2 points to get your radius. And that's that assignment. Good luck.